The Nordic marine ecosystem. More than 70% of the Earth's surface is covered by oceans. In the north, we find the Arctic Ocean, the Barents Sea, the Norwegian Sea, the North Sea and the Baltic Sea, and all Nordic countries have coastal access. The seas of the north stretch from southern Denmark to the Arctic and can be divided in many ways. Here they are divided in 3 zones. The Arctic zone further north, the subarctic zone, and the temperate zone further south. Different animals live in the different zones, and the number of species are countless. A few examples of the marine mammals in the Arctic zone are the polar bear, the beluga whale, and the harp and hooded seal. Minke whales live mainly in the Arctic and subarctic, and the harbor seal may be found in all 3 zones. White-beaked dolphins and harbor porpoises are primarily found in the subarctic and temperate zone. The majority of the people in the north live along the coast and interact directly with the marine ecosystem. This map shows human population density. The most colored areas are the most densely habitated. 80% of Norway's population live within 10 kilometers off the coast. The country has an important fishing industry, but 46% of the country's total export value comes from the petroleum industry, which is present in a vast area of the Norwegian waters. The sea is an indispensable resource to humans, and we use it for many things: fishing, transport, natural resources, and recreation through sail sports, cruises, or swimming. Conservation aspects. The fact that humans are so highly dependent on the sea makes conservation essential, both for our own sake as well as for the health of the ocean itself, and now more than ever. The major conservation issues today all relate to human activities, and 3 of these issues are ocean harvesting, pollution, and climate change. Ocean harvesting. Humans have always been dependent on the ocean and its animals, and demands for food, oil, and the alike are higher than ever. This affects the marine animals, but also the marine environment. Trawlers strip ocean floors and leave them as deserts without plants or other living creatures. Bridge constructions can alter the currents in the water and thereby change the oxygen balance in the area, and busy harbors and boat activity disrupt fish and mammals' migration routes. As an example, the Baltic Sea is one of the northern oceans facing serious threats.
The major threats are land-based pollution originating from the agriculture, there are the oil spills and overfishing, and the most imminent threat as we see it is the sand dredging, which is removing the top layer of the bottom of the sea. And since trawling have been prohibited since 1932, we have quite a unique life at the bottom of the Baltic, and this is destroyed as it's removed by the sand dredging.
One of the biggest issues in all waters is overfishing. In 2006, 81.9 million tons of fish were captured just in marine waters. Around 80% of all fish stocks are fully or overexploited, and overfishing occurs all around the world, with the Nordic waters being some of the most overexploited waters through time.
Since 1950, the area fished by global fleets has increased tenfold. 100 million square kilometers are fished today with such intensity that these ecosystems are already severely damaged. That's around 1/3 of the world's oceans.
Pollution. Sadly, where there is usage, waste often follows, and human-caused waste is the major source of pollution in the marine ecosystem. This is represented both by visual waste, such as plastic, but in the north, invisible waste poses a much greater threat: spillage and washouts of nutrient and toxins. Humans and human industries are the main source for toxin pollution. Some of the industrial toxins are persistent organic pollutants found in pesticides and solvents, and petroleum, hydrocarbons, heavy metals, and radioactive substances. In the subarctic zone, salmon farms are a major source of pollution due to the net pens the salmons are kept in the open water. From these pens, waste is discharged directly into the ocean. Feces containing pathogens and leftover feed laced with chemicals such as nitrogen, phosphorus, and copper. In 2000 to 2001, nutrient discharge from aquaculture in the northeast Atlantic was estimated to around 40,000 tons of nitrogen. The main part of the Baltic Sea is in the temperate zone, and it is surrounded by agriculture countries. The Baltic Sea is today one of the world's most polluted waters due to extensive discharge of nutrient and toxin-rich waste through several decades, half of this discharge coming from agriculture.
The land-based pollution is a problem because the higher nutrient level will lead to algal bloom, and these algae will outshadow other organisms, and the degradation of this higher amount of dead organic matter will lead to oxygen depletion, and in the end this will kill the whole ecosystem.
During the 80s, discharge of organochlorides to the Baltic Sea caused a major decrease in the reproductive rate in seals, threatening their survival in the area. A lot of effort has since been put into reducing this threat towards the seal population. However, in 2000, around 25% of the female ring seals were still not fertile. Organochlorides also accumulate in Arctic animals, especially the top predators, whales, seals, and the polar bear, and in the latter, organochlorides have also been associated with changes in the reproductive organs. Accumulation of toxins and heavy metals in top predators in the Arctic is affected by many mechanisms, and besides the pollution aspect, climate change also has an effect on the contamination load. Temperatures, ice coverage, and ocean currents act together in a complex manner, and the connection is still under investigation. Climate change. One of the most obvious consequences of climate change is the progressing reduction of sea ice, which affects the Arctic marine ecosystem and its inhabitants directly by causing a loss of sea ice platforms. This loss of sea ice leads to a reduction of suitable habitats for feeding, resting, and breeding. For instance, ribbon, spotted, harp, and hooded seals all breed on the packed ice, and the ringed and bearded seals are ice-associated year-round, including while raising pups. The reduction in sea ice also causes a change in movements and distribution of the ice inhabitants, which results in increased drownings and strandings. Walrus utilize the sea ice as resting places to reach bivalve mollusk beds that otherwise would be too far from the shore. With less ice, the walrus are becoming more packed in the areas they can reach, without depending on ice platforms to rest on. Polar bears use the ice as a hunting platform and transportation corridor. For both these species, the reduction in ice makes searching for food risky, sometimes not even possible, and it may cost them their lives. Some animals of the Arctic rely on the packed ice as viable substrate for their prey. In the winter, narwhals, for example, feed intensively on benthic fauna in areas with packed ice. Climate change is also indirectly affecting marine ecosystems by changes in the transmission of infectious diseases. Increased host densities are occurring due to the decreased habitats available, causing an increase in density-dependent diseases. More epidemic diseases are also occurring because of expansions of a host and vector range. Morbilliviruses provide us with an excellent example of both changes. It has the potential to cause die-offs of thousands of seals when the density of susceptible seals in an area is too high, and thereby facilitates the spread of the infection, making it a density-dependent disease. In 2002, the phocine distemper virus, a morbillivirus, killed around 21,000 seals in Skagerrak and Kattegat, halving the seal population in the temperate zone. This morbillivirus outbreak did not spread to the Arctic seal populations that live under very different conditions than the seals in the temperate zone. However, if such an outbreak occurs in the future and the temperate seals have expanded their habitat to the north due to climate change, there is a large risk of spreading morbilliviruses to the immunologically naive Arctic seals, risking an Arctic outbreak. The changes occurring due to global warming are complex, and the interactions between changes in the animal's habitat, diseases, loss of body condition, and the increasing contaminant load results in an increased susceptibility to endemic or epidemic diseases within the marine animal populations. The marine ecosystem is the largest ecosystem on the planet, and it cannot be understood without looking at its interactions with other ecosystems. Its complexity is as deep and undiscovered as the ocean itself, but one thing we do know. The sea is vulnerable, and we humans have a huge responsibility regarding the massive changes we today experience in all levels of this big blue wonder.